Session 3. Here are the answers to exercise number 5. General notes are found throughout the plan. There may be a set of sheets within the plan entitled General Information or General Notes. General notes give the contractor specific information or instructions on a number of items of work. Sheets 2-N1 and 2-N2 are general information sheets, clarifying items not found elsewhere on the plans. Remember, general notes can be found throughout a set of construction plans. I'll point these out as we go through the upcoming slides. Turn to sheet 2-S. This is the summary of quantities sheet. It shows all the pay items for each of the groups we discussed earlier. For each group or section, the item name, item quantity, and item unit is given. Sheet 2-S shows the 5 groups that were on the title sheet. We'll look at group 4, culverts. Here are all the items associated with group 4, culverts. The item name is in the left column, the item quantity in the second column, and the item units in the right column. The item units can be given in lump sum, cubic yard, linear feet, as shown here. Other item units include hour, pounds, tons, square yards, or acres. Look at the other group items to become familiar with names, quantity, and units. View angles. A set of construction plans will show drawings from different angles. Depending on what the designer wants to point out to the contractor, they will use a particular angle to provide a better understanding. Here are 4 view angles found on most construction plans. Turn to sheet 3. Sheet 3 has 2 views. The top view is the plan view. The plan view depicts a section of road from a bird's eye view. You are looking down on the project or a portion of the project along the center line. Here is a larger view of a portion of the plan view. The information call-out boxes give instructions to the contractor. Also notice the stationing numbers. They are telling you exactly what is to be done at that point on the project. The bottom half of sheet 3 is the profile view. The profile view depicts the vertical plane along the longitudinal center line of the road, expressed in elevation or gradient. You are looking through the project, sometimes referred to as a worm's eye view. Plan sheets like sheet 3 are called plan and profile sheets. Here is a larger view of a portion of the profile view. Along the outside edges are the elevations. There are also information call-out boxes giving instructions and benchmark information. Station numbers are found along the top and bottom of the plan and profile sheet. Turn back to sheet 2-T. The cross-section view depicts a section of road viewed vertically as if cut across the width of the road. There are two more cross-section views on sheet 2-T, the typical section at bridge ends and the typical channel section. Remember, a cross-section view is across the width of a road, street, bridge, channel, etc. The typical view depicts features of a particular design, installation, construction, or methodology. Here's an example of a typical view for the installation of a trench. Here is an example of a typical view for a field splice weld. As you look through the plans, see how many typical views you can find. Remember to look for features of a particular design, installation, construction, or methodology. Drainage structures. A construction project may have several types of drainage structures. Here's a list of drainage structures that may be found on a set of construction plans. Sheet 4 on your set of plans shows the cross-section of a culvert installation. Information found on sheet 4 includes the culvert inlet elevation, the outlet elevation, and notes about the culvert, which include the station, culvert type and size, the amount of excavation and fill. The notes also give hydraulic information, the drainage area, and the peak discharge or design year storm, which we will discuss. Sheet 7 on your set of plans shows the sectional elevation of the new bridge for this project. You will see the centerline stationing and elevations of the abutments and bents, and the station number of the center line of the bridge and channel. We will discuss the bridge plans in more detail. The formula Q equals CIA is the rational method equation for determining peak discharge for a drainage structure. You may not be required to calculate a structure's peak discharge, but it is important that you know what it is and how it is determined. Q is the peak discharge a structure can handle. C is the runoff coefficient, or the amount of rainfall that will run off a particular type of surface. I is the rainfall in inches per hour, and A is the drainage area in acres for the drainage structure. This chart gives you values for the runoff coefficient C. The runoff is different for different types of ground cover. As shown here, the amount of runoff for cultivated land is less than that of an asphalt street. Here are notes for a particular culvert pipe. The drainage area is 36 acres. The Q, or peak discharge, is 80 cubic feet per second. The design year storm is always noted by the number next to the Q. In this case, the number 10 means the culvert is designed for a 10-year storm. A 10-year storm refers to the rainfall totals that have a 10% probability of occurring at that location in that year. Encountering a 10-year storm on one day does not decrease the chance of a second 10-year storm occurring in that same year or any year to follow. In other words, there is a 1 in 10 or 10% chance that a storm will reach this intensity in any given year. Likewise, a 100-year rainfall event has a 1 in 100 or 1% chance of occurring in a year. A 50-year rainfall event has a 1 in 50 or 2% chance of occurring, and so on. Exercise 6. Use sheet 3, Friend South plans, to answer questions 1 and 2. Use sheet 4 of the plans to answer questions 3 through 5. Stop the video. After completing the exercise, play session 4 to continue.